Hello and welcome. Thank you all for joining us today on this session about AutoML. I'm excited to talk to you guys about creating machine learning models in minutes using AutoML, and specifically we'll be talking about Amazon SageMaker Autopilot. Now, in terms of the agenda, how I wanted to use this time, we'll quickly talk about what is AutoML. Then we'll get into an overview of SageMaker Autopilot and dive deeper into its capabilities. Finally, we'll wrap it up with a demo of Autopilot and talking about a few examples of how customers are using Autopilot today. So what is AutoML? You may have heard the term automated machine learning or AutoML, and you may have heard different folks talk about it differently. Perhaps you heard of a single click or a single call approach to automate your machine learning process. Or you may have read about the low code, no code approach. Some folks also talk about AutoML as applying machine learning to machine learning. In the spirit of what this really means, and I think by now there's a well-established sense of what AutoML is that it allows you to remove that tedious and iterative and time-consuming work across the machine learning workflow, whether it's from data acquisition, where you might be prepping the data and then going through feature engineering, to the actual training and tuning piece for building the model, and finally operationalizing it as you think about deploying the model or monitoring the model, retraining, so the entire workflow. What that really means is you have to spend less time worrying about these lower level details, and you can focus more of your time on actually consuming these machine learning models to improve your business outcomes. So who is AutoML for? Who can actually leverage AutoML? I'm assuming today in the audience we have a varied set of folks. We may have data scientists and expert machine learning practitioners, or you might be someone who is just getting started with your journey in machine learning. So whether you're a novice practitioner or an advanced machine learning practitioner, AutoML is something that can actually help you. I'm assuming there are also lots of folks in the audience today who are either on the business analyst, IT analyst side, or also machine learning engineers in the MlOps world. And so no matter what your role is, there are ways you can leverage AutoML, and we'll talk about that. So I think this slide provides sort of a good overview of what I was just talking about, in the sense that with AutoML, you're essentially simplifying machine learning. And there are various aspects of the machine learning process that you can actually leverage with respect to AutoML and take advantage of. As I was just talking, AutoML is something that all practitioners can use, whether you are a business user, a data scientist, or a developer. AutoML, there are AutoML solutions from AWS that you can actually leverage. And the way we think about AutoML, and this is super important, is actually maintaining the full transparency. So AWS makes it easy to help you dive deep into the models that are generated by AutoML. So that's why, going back to my earlier comment, AutoML capabilities help meet you where you are in terms of your expertise level and skill set. And we'll talk through more in detail as we go through the demo. Now, just a quick overview of Automl offerings from AWS. If you look at the entire portfolio, there are lots of AutoML capabilities that you can actually take advantage of. So for example, here with AutoML for language, you have offerings like Lex, Transcribe, and Amazon Poly. I'm not going to go through each one of these in details, but similarly for vision, You have capabilities such as Amazon Lookout, Amazon Recognition as an example. Likewise, for business metric analysis, you have offerings like Amazon Forecast or Amazon Fraud Detector, and so on and so forth. Now, if you were to look into SageMaker specifically, Amazon SageMaker, you have AutoML capabilities sitting within that. And specifically today, we'll be talking about Autopilot, which helps you automatically build and train models for the data set that you bring in while providing complete visibility into the machine learning models that it builds. So Amazon SageMaker and SageMaker Studio are sort of the vehicle where Autopilot resides. So as you might be already aware, Amazon SageMaker Studio is a fully integrated development environment for machine learning, which enables you to collaborate at scale, provides you easy experiment and management capabilities, along with, of course, Autopilot for helping you get started and accelerate your model building, as well as providing you end-to-end tools and a unified visual interface. Okay, so jumping into actually Autopilot now. As I mentioned earlier, Autopilot essentially builds, trains, and tunes machine learning models automatically on your behalf based on the data that you bring in. And while it does so, it gives you full control and visibility. Whether you're an expert practitioner who wants to get into the details of the notebooks that are generated, or you want to review explainability capabilities, explainability reports, Autopilot provides you that visibility. And we'll go through this in a lot more detail in the demo. So how does Amazon SageMaker Autopilot actually automate this model building, right? So very simply, actually, just in terms of what's needed, what do you do when you want to come and use Autopilot? So you simply come in with your data set. Today, Autopilot works with tabular data set. So you bring in a CSV file which has your tabular data set. This may be in S3 today. And then with that, you just start an experiment within SageMaker Autopilot and let that run through. At the end of the experiment, you actually get a list of models, and we'll see that very shortly. And then all you do is you go through and identify the model. It identifies the best model, but you look through the models and you select a model to deploy and make predictions. So, at a high level, as you can see, you don't really require extensive machine learning capabilities to use Autopilot. You just come in with your data set and the prediction or the problem type prediction that you're trying to make, and then you let Autopilot run through the experimentation and provide you a model that can be deployed.
You are watching MlOps Series, live from Bootcamp AI.
Now that sounds super simple. And to truly appreciate that, I think it helps as you kind of think through how would you do this process manually. As you can imagine, if you're manually creating a machine learning model, that process tends to be a very iterative and interactive process. So at the very first step, you may be starting with just your data prep and data processing, looking through feature engineering. Maybe you're just assessing the quality of data, going through basic imputation techniques or handling outliers, applying normalization. So kind of just doing that pre-processing work up front. And then after your prep is done, you move into the second phase here, which is sort of the training phase, as I'm showing here. And through the training process, of course, you're looking through lots of algorithms, choosing the right one based on your experience, and going through this iterative process to try multiple algorithms. Again, the second part here is really the tuning aspect, where you're now also controlling a lots of knobs and tuning and making finer adjustments to get a better model performance. Uh, Typically, you might start with a broad range of hyperparameters, and then you kind of work through that to tune and get to the performance that you're looking for. And so through these three steps, there's a lot of iteration, and you may go back to as you kind of explore uh, the model training, you may go back to some prep, or as you do tuning, you may go back to your training aspect of algorithm selection. So in that sense, it's not really a linear path, and it is very iterative, um, and it can take considerable amount of time if you're doing this manually. And so that's the beauty and the power of Autopilot. It'll actually automate all of this for you, and it gives you this single API call that you can actually use to start Autopilot experiment and get the final optimized models for your data set. And you can do the same thing with few clicks in Studio that I'll actually show you in the demo. Okay, so what kind of problems can Autopilot solve today? As I mentioned earlier, Autopilot works with tabular datasets, and today we support regression and classification problems, both binary classification and multi-class classification. So whether you're trying to predict a continuous value of an input or of a feature, or you're trying to place an observation and classify it in two or multiple categories or classes, you can do so, right? So what does it really mean for your business set of problems? This actually, just with regression classification, it actually opens up a lot of business scenarios that you can handle or use cases, whether it's a very important customer churn prediction, um, or predicting customer spend and lifetime value, or classifying a risk of loan or default, or trying to identify customers who may be likely to respond or participate or respond to a sales campaign, as an example. So there are lots of use cases that open up with Autopilot. As I mentioned earlier, what do you need to do? You need to come in with your raw data set. This is tabular data set, and today it needs to reside in Amazon S3. So you bring in your tabular data set, upload it in an S3 bucket, and then to get started, you just specify which is the target column that you're trying to make a prediction on. From there on, Autopilot does its job. It'll go through the model creation exercise, of finding the algorithm, training and tuning, and get that done right so that you have the right model for your data set. Behind the scenes, of course, it'll do the split in terms of training data set and validation data set. But again, you get the visibility and transparency in terms of the notebooks, so you can understand what Autopilot did. But you don't really have to manage any of these pieces. Finally, the output of Autopilot is this leaderboard, or the model leaderboard, that allows you to find the best model for your needs and then deploy that. Okay, I'm going to quickly walk through some of these details because we will get into this in the demo. But essentially, I mentioned a couple of times that Autopilot does share these notebooks uh, at the end of the experimentation. And so there are two sets of notebooks. There's this candidate generation notebook and data exploration notebook, both of which essentially give you all the details, and these are both runnable notebooks. So for the data exploration side, it actually gives you the detail of the data set and the statistics, number of rows and columns, and maybe some suggested remedies as well in terms of what you can do with to if you were to sort of come in again with a similar data set. Now, besides the actual list of outputs or models that get generated with Autopilot, we also include explainability reports. So, for example, I'm showing here the feature importance, which will help you understand and explain how a model was created and how also each of the features is actually contributing to the model. Which are the features in your dataset that are actually impacting the model the most. Okay. And again, we'll see this in the demo, but the other notebook is the actual candidate generation notebook. And so it kind of shows you what happened, what's actually happening end to end, as well as it gives you some controls. If you are comfortable using notebooks and you wanted to tweak certain aspect, then it actually highlights, what are the maybe some of the changes that you can do or you may want to consider. So with that, I'll actually shift gears and get into the demo.
All right. Perfect. So what we've done for people catching up here, we really just went sequentially through the first 0-1 intro section here. And please make sure also we always do have obviously curious people here that try to move ahead. Feel free to do. Just please always make sure you're executing sequentially and making sure that all the code runs successfully. All right. So yeah, just run through the 0-1 notebooks. There shouldn't be much of an issue here. It's really just making sure we have an S3 bucket where we can drop data for today, and also giving this SageMaker environment a little bit more permissions than it would normally have, because this is our main environment for this workshop, and we're doing a lot of things programmatically from this instance. So this is why we need to have permissions in place. All right. So this was 0-1, and quick outline here what we're going to touch on today, and you also see this in a more visual way on the GitHub README. So we're going to walk you basically through an end-to-end workflow, an end-to-end development lifecycle of a machine learning model. And for this workshop, we're using an NLP use case. So we're doing natural language processing. And we're doing this with the Amazon Customer Reviews dataset. So for those of you who have been to Amazon.com, the website, the marketplace, and you might have looked for a product to buy, you might have seen that there's always star ratings and other customer reviews. So did people like this product? Yes, no. And at least I always jump in there and double check before I buy something. That is really like, meeting the expectation, and there's no bad reviews. And this is basically a data set that Amazon published. So there's 150 million reviews in the data set available, which you can use to explore NLP. So perfect, right? Because you can go through all of those reviews and then explore and use that to train or fine-tune an NLP model. And this is exactly what we're going to do today. So starting basically from 0-4, ingest, explore, prepare, train, optimize, deploy. We're going to build this as a manual pipeline. And then as a bonus chapter here in 10, we're going to show you how you can automate those steps together in a pipeline. And we're using here step functions from AWS as a service. And in the second big part of today's workshop, which will probably roughly be in 6 hours from now or 7, we will also show you how you can run Kubeflow on top of EKS, which is Amazon's managed elastic Kubernetes service, if you're looking maybe into Kubeflow as a tool set to run your machine learning. All right, and before we start with this ingest, we wanted to show you actually a couple of really cool things that the cloud also offers. And we're starting with AutoML. And you might have heard of automated machine learning already. And there's a couple of use cases for AutoML. Sometimes people think, well, you know, I am the machine learning expert, right? I don't need any automated things. I know what I'm doing. And this is certainly true. In some cases, you might just look at AutoML to offload some of that task, right? Maybe you want to start from a baseline and then see how good the service or the automated algorithms work. And then, you know, you can start from somewhere, have a look, and then fine tune, develop, edit as much as you need. Or indeed, you're on the other side of the spectrum and you don't have that much experience with machine learning and you want to have a quick start, right? So I think those are pretty much the large two groups that might benefit from AutoML. And we want to show you what you can do here on top of AWS. So this first one here, and it's just, I'm opening up the overview here, which basically just shows the image, is a quick introduction. So automated machine learning, the purpose is really, if you think through the steps needed, you have data at hand, and then you need to analyze the data, check the quality of the data. Are there missing values? Is the data good enough for the problem I try to solve? And then you probably need to clean and validate the data. You might do some feature engineering. You need to kind of maybe combine some columns together, reduce the dimension, the number of features and columns in the data set, etc. Right? And then you start exploring, prototyping a first model. You write code, you choose an algorithm, and just iterate, right? And see how good the model performs. And you do this over and over again, trying to come to a good performing model. And this might really take some time, right? And automated machine learning is really targeted at automating those steps for you. And SageMaker has a new service that got launched at last reInvent, which is called Autopilot, which takes those steps basically. So you just provide Autopilot with your raw data in a CSV file in an S3 bucket. And then Autopilot looks at the data set and it analyzes, runs some statistics, tries to understand the data, and then defines which algorithm is best to solve the problem. And it also tries to define the problem actually, so you don't have to tell it whether it's regression or classification. So Autopilot will look at it and say, oh yeah, I'm pretty sure this is a classification problem here. And then picks the algorithm or a choice of algorithms, and then starts developing those model and machine learning pipelines. And with pipeline, I'm referring to what is needed to prepare the data. What is needed in terms of feature engineering. And then it starts training the model and it tunes the hyperparameters. And then at the end, it presents you, and this is something which sets Autopilot pretty much apart from many of the other automated machine learning offerings that are available today in the market. Autopilot documents everything. So it's a very transparent approach to this, what's sometimes a more closed approach to what's going on inside. And here, Autopilot produces basically 2 new Jupyter notebooks, which you can open and see, and they document what Autopilot found, right? It also presents you the code. So it generates the Python code needed to do the feature engineering, etc., the model training, model tuning, and also wraps this up in a Jupyter notebook, which you as an expert could take and review and say, well, that makes sense, or you can tune it further, right? And so pretty exciting. And then you can choose the best performing model candidate. So Autopilot will present you a list of potential candidates here. And for example, just pick the best one and deploy it right away as a prediction endpoint.
You are watching MlOps Series, live from Bootcamp AI.
So sounds cool. And let's see how we can do this, right? So I'm just executing the last cell here, which shuts down the kernel. Okay. And for that, we actually do a little bit of data preparation here. So let's open up the 01. So we want to like guide Autopilot at least a little bit in the direction we want to have it. You could also do it without feature engineering, but the more curated data you present it, obviously, the less work Autopilot has to do, and the more you can focus on the model performance here. All right, and here I do again, because I always start talking and forget to run the cells, I do a cell run all. And let's see, so here's the link actually to the Amazon Customer Reviews dataset, which I mentioned. So you can click here, and as I said, Amazon published this Customer Reviews dataset, so you can use that, pull that down to an S3 bucket of your choice, pull it down locally, play with it. It contains over 130 million, I think up to 150 million even, customer reviews from the years 1995, that was the first review here, up to 2015. And the data is available, here you can see, in a couple of different formats. It's offered as tab-separated files, TSV files, so similar to comma-separated, just tab-separated, very structured, and also in Parquet. And Parquet is an optimized columnar binary format. And this comes in handy if you're running, for example, SQL queries, right? Here, for example, you do a select product title star rating from the table, where the product category might be books. And especially if you're filtering by product category, etc., it makes a lot of sense if the data is optimized for this columnar query style. Whereas machine learning is normally a row by row, right? Where you're feeding a model, reading in the features, the examples, and then try to make predictions. So machine learning, generally more row oriented, but if you're running query data analytics, that is generally speaking often optimized for columnar. All right, those two are offered. Here you can see how you can start working with it, play around with it. And that's what we're doing in here. So the data set has a specific schema, right? So basically think of it as the columns in your table. So we do have marketplace, which is a 2-letter country code from the marketplaces Amazon.com operates. So the majority of reviews in this data set is from the US marketplace, but there's also a couple of multilingual. So I think there's also the German marketplace with German reviews. I think there's French and a couple of more. So also a random identifier which replaces the customer ID. There's a unique ID for the review ID, a product ID, the product parent family, product title, category, and then the actual star rating. So for our use case today, we're specifically interested in seeing review star ratings. So a rating 1 to 5, and 5 stars is the best. So if you really like the product, you probably gave it a 5-star. If you didn't like the product at all, you gave it a 1-star. There's also a flag for was the vote helpful to others? How many votes did the reviewer receive? Is the reviewer part of a reviewer loyalty program called Vine? Is it a verified purchase? The headline of the review. And then that's another important one here, the actual text of the review. So what has the reviewer actually written? And the date. So this is the structure. And we'll see this many times today through the workshop. And then again, here we're pulling in our SDKs, nothing too exciting. And the first step here, and this is really preparing data for this AutoML. This is not yet doing anything at scale. We just want to quickly show you the data and actually get an Autopilot job started soon. So what we're doing here is we're copying the public data set. And you can see here it's using the AWS CLI. You could use this either, we've seen that before, if I do this %bash, then I could do AWS F3 any CLI command, or if you don't do this %, just an exclamation mark, which will also say execute this as a CLI command. So this is what we're doing. We're basically branching out here to the CLI and running the AWS CLI command. It's just a very simple way. And copying from the public bucket here into a local data bucket. And if I go here to the folder structure, you should see the data folder coming up. And here is locally on our instance this TSV file, which is the reviews for the product category of digital software. And we will learn about those categories way more in the next sections here. All right, so just think of it, all the reviews from the data set that are of the category digital software. And we've chosen that because it's one of the smaller ones, right? We're doing a lot of exploration here in the notebook, which we just want to be quick. And also, if we're running many of the machine learning trainings and tunings today on large data sets, it would run for hours. And as the workshop, we didn't want to do a week-long workshop, just a one-day workshop. We need to make sure that all of those jobs actually finish in a reasonable time so we can see the results. And this is why we're picking a smaller data set here. Obviously, for productionizing use cases, you would look for as much data as you can. All right, so next we're going to read this local file into a pandas data frame. So pandas data frames are just a nice structure here to visualize and play with structured data. So perfect for our TSV file. We can also say here it's gzip compressed and delimited by tabs. And then here from the pandas library, it's a data frame. And on the data frame, you can do a shape, which shows you how many rows and features we have. So we have 100,000 reviews and 15 features, columns basically. And you can do a sneak peek. So let's do pull the 5 first rows and see how the data looks. And here we go. So marketplace, US, we're pulling in a US marketplace review data set, some randomized customer IDs and review ID, product parent, the title. And yeah, I can see here digital software, right? So Norton Internet Security 1 license, the good old software, actually got a star rating of a 5. Wow. So star ratings, helpful votes, total votes, you can see verified purchase, yes. The review headlines, so you can see what people put in here, and the actual review text and the date. So I think pretty straightforward to understand how our data looks like for today. All right, so another thing we can do pretty exciting is to visualize the data here in this notebook. So to visualize, you can use a library called Matplotlib, which we can render inside this notebook here. We can optimize for retina screens. And what we're doing here, we're taking this data frame, which holds all of our data now, and we're just grabbing the column star rating and the column review ID. We group that by star rating, and we're doing a count, and then we're plotting. And we're plotting as a bar chart and giving it a title. So pretty self-explanatory. And the result you can see here. So we grouped by star rating and counted the number of reviews, right? And what we can see here as well, if you're familiar with data science, it's a very unbalanced data set. Right? This is the term. So we can see that there's way more reviews that got a 5 than there's reviews that got a 2. And I guess it's kind of understandable, right? I mean, people are getting way more excited to give a review once, you know, it's a great review. They're super excited and they want to share this. And probably also when it's like on the other extreme, right? When you absolutely didn't like it. But if it's just okay, I guess less people are inclined to spend the time to write something. So this is explainable, but not really the best data for machine learning. If we would pass this information and this training set now to the model would probably pick up that there's more chance to make the right prediction if I do a 5, right? So the model would learn to predict more 5s than to predict 2s. And we want to keep any bias here out of our model, right? We don't want to train the model on learned distributions. We really just want to train a model that we can give any review text and the model will classify the star rating. So this is our goal today. So give it any text and the model will say, this is a 5-star rating or this is a 2-star rating. So for this purpose, we don't want to have influences coming from a pre-learned distribution that is caused by whatever, right? All right, so what we do next to help here is to balance the data set. And we can do this with a couple of simple just Python commands here. We're pulling in scikit-learn as a library, which has some utils and also can do a resampling. And we're basically creating different data frames for each category here, for each star rating. And then we're counting the minimum here. So we're checking for each category, what's the minimum number. And basically, you can see here, we're going to end up with finding that 2 has a minimum and then cutting down the number of reviews to that minimum available. So all the categories have the same number. There's more sophisticated ways to do this. You can also like upsample to create more reviews for the other categories. In this case, we're just keeping it simple and downsampling here. So after we've done that and we plot, you can see now we're having roughly 7,000 reviews per star category. So this looks much better, right? So the data set is really balanced. So our model can learn the prediction, the classification of the star rating really just based on the text. And we can double check that the data looks still good. And as a next step, what you would also do always is to split the data into different data sets. So having this big data set, we're going to now create a holdout of 10% for testing and validation. So let's keep 90% of those reviews to train the model. And then you do run, after each model training step, you validate how good the model is performing. So the model will actually like react on those data. And then once you're done with the training, you want to have another small data set to really test how the model is performing on data which it hasn't seen before. So this is why we have like 2 holdouts here. So we're first cutting into 90 and 10%. So we have train and holdout. And then we're cutting the holdout data set again 50%. So we have basically 5% left from those 10 for validation and test. All right, just for those of you who like visuals, here we go. So we can plot this as well. So we have 90% of the training data for training. And we do have a holdout for model validation 5% and another 5% for test. And you could really choose different values if you have more data. We have now just downsampled, so we don't want to like keep too much data out here. But in general, you could also do 80, 10, 10, for example. Or you want to do 70, 15, 15, depending really, I guess, on how much data overall you have. Up to you. All right, we're just running a couple of visualizations here, making sure it all looks good. And as a last step, we're cutting down those 15 columns to just really have star rating and review body. Because we also don't want to train the model on if it's a verified purchase or if the reviewer is part of the Vine program or something, right? We really just want to give Autopilot 2 simple features, star rating and review body, and please learn to predict the star rating from any given text. All right, so this is how our data set looks like, star rating and the review text. And we're now writing out the data into a CSV file, because if you remember, Autopilot expects the data set to be presented as CSV in an S3 bucket.
You are watching MlOps Series, live from Bootcamp AI.
So here we're just really creating the CSV file. So we can just on the data frame call the toCSV, giving it a name that we're creating here, saying no index, and keep the header information. So Autopilot needs header information, column names. And we're uploading it to S3. So this is happening here. So we do a session upload, and saving this to our lovely S3 bucket. All right, double checking that the variable that we created is set on this location. So we're keeping track of where we're storing this, right? So we're creating a variable here, header train path, which will remember exactly where we stored this. All right, and we're creating another CSV. We're going to show another service called Comprehend, which is a completely fully managed AI service for natural language processing, where you don't even have to train a model necessarily. But we want to show you how to use that service. And even if you want to, you can fine tune it to your specific use case. And funnily enough, Comprehend expects the data also as a CSV, but in this case without header. So here we're actually setting the header false, also exporting into CSV, uploading to our S3 bucket, and again, making sure we remember how the file is called. All right. And what you can see here now, and this is also something you will see over and over in today's workshop, we're storing those variables with a command that is called %store. And this is yet another Jupyter magic, what it's called, a built-in functionality from Jupyter to actually keep track and store those variables in the instance. So we're doing this so we can pick them up in the next notebook. Otherwise, they would have been gone and not known once we start the following notebook. So for us to be able to carry all of those along, we're just doing here a simple, very simple implementation inside the Jupyter instance. And this is why it's important to run all the notebooks sequentially, because later notebooks will pick up those variables. And if you never stored them, they cannot retrieve it. And you can double check here running the %store, and you can see we stored here the two in our little Jupyter built-in mini database. All right, and the last cell closes this notebook. Kernel shutdown. All right, so a lot of introductions here to the data set and first steps here to prepare a little bit of data and visualize. So let's close that. And I'm still in 02 Automl. So we've seen the prepared data set. So let's actually start the training jobs, and they will run for a little bit. So let's open 02. And 02 here, train reviews Autopilot, will now show you how you can fire up and create an Autopilot job on this data set. And as I said in the beginning, Autopilot really implements a transparent approach to automated machine learning. So we're presenting it here with the data set, which we just created. And then Autopilot will have a look at the data, analyze, run statistics, does feature engineering, so it prepares the data, picks an algorithm, and then trains and tunes the model. And it will give us the findings presented. Obviously, we can check the metrics, we can check for the model candidates, which Autopilot presents, and also generates Jupyter notebooks. All right, so this notebook will run for a long time, 20 minutes. So let's do a cell run all. Let's get the work started. So yeah, in case you're seeing any errors, make sure you run the previous notebooks. This is the first example here. We're picking up on those generated files that we just produced. So if you haven't done the notebook before, obviously this one will show some errors. So make sure you executed those. All right, so let's see what's happening here. The notebook will run 20 minutes, so just keep it open. And if you line up all the cells with the run all, it's going to do the job and it's going to finish at some point. I'll explain what's happening. And if the notebook is still running, we will move ahead and then we can revisit the outcome later. All right, so first of all, again, pulling in all of our SDKs. Guess this one is familiar now. And here you can see, this is the first step where we're retrieving, I think officially it's called refresh. I always say retrieving. So we're retrieving the variable that we stored, header train S3 URI in the previous notebook. We're doing some programmatic check here just to make sure in case you missed it. If you have not set this variable in the previous notebook, if you have not run the previous notebook, it will print a note here for you. So we're just trying to explain and help you along in case you missed something. All right, in my case, it's not printing, so I do have a value set. And here I do the print, and I see this is where we stored this CSV file for Autopilot. And I also do have here name and location. All right, so we're preparing, let's have a look at the prepare data again. So I just added this here basically. Let's copy it down. We would have it here, but just in case we're running it in another environment, pulling it into CSV, having a look. So what we're passing to Autopilot is exactly that data set with 7,000 rows. Here we just have quick the first 5 rows. So a star rating, which is the 1 to 5, and a review text. All right, let's move ahead. So first thing we do, we set up in a 3 location where Autopilot can drop any outcomes, any results, any generated assets. And here we're creating just a folder structure for our 3 buckets. So let's call this models/Autopilot. And we're creating this in our default bucket here, okay? So we're creating this F3 string by filling in the bucket, which is the default bucket here, and this prefix, which we created here, models in Autopilot. Let's do a print, and this is basically the F3 bucket where all of the results will end up. All right, next step, we're going to configure now Autopilot. So let's say we want to have 3 model candidates for this problem, right? And you can scale this up to, I think, up to 250. So you could receive or tell Autopilot to check for 250 different combinations to find the best models. This would run for a couple of hours, and I guess all of us have better things to do on Sundays. So we just go for 3 candidates. So this will just limit the execution time, but gives us enough insight to what's happening. And then we're defining completion criteria. So you can define how long the jobs should run, just to set limits, like the maximum candidates, but also how long a single training job in seconds should run, or the maximum time the overall Autopilot job is allowed to run. Just good to set some limits here, not accidentally creating jobs that run for days. Although I think it has a default timeout as well, so don't worry. Input data configuration, this is where we set the location to our training data. And as you can see, for any hints to Autopilot, we're really just giving one hint here, which is the target attribute name. So basically telling Autopilot, I want to have a model predicting on star rating, right? So this is the only hint we're providing. We want to predict star rating, and we're passing in the output path location where to drop all of the generated assets. All right. So we're almost good to go to start the job now. So let's create a name for the Autopilot job. So we just pull in here libraries to create a timestamp. And then this is our job name, AutoML-DM, and the current time. And we can create the job. So on the SageMaker client, which we created through the SDK, we call create AutoML job. And here we're passing everything that we set up. So we set up the name, the input configuration, showing where the training data lives, where to drop results and the output, and any job configuration like give us 3 candidates. And we're also giving an execution role, which is our team role here. And here you can see why it's important to have permissions, because we're doing a lot of things here. All right, and this starts the Autopilot job. And we can keep track here what's happening. So we can check for the job description. So you can see here an AutoML job. This is the name. This is the specific ID, the RN from Amazon, where to identify the different resources. We can see the input configuration, so everything is in here. Looks good. So another programmatic check, just to double check that everything started up okay. So this is really just checkup code. And if you see an OK, you're in a good shape. If you see something else here, make sure you've run the previous notebooks and you're executing cells sequentially. Again, if everything works as expected, you should see here the OK. And then we're pulling here the job information. So given that we have a job that is running, obviously, we're pulling here for the job status and the secondary status. And this will now show us in which phase Autopilot is currently in. So it's currently in progress and it's analyzing the data. So this is the first step when it looks at the training data set and checks if there's any data quality issues, basically. And the funny thing is that after this first phase, it already creates those notebooks for us. So pretty quick in the whole flow, we can have a look at those assets. I just quickly show you what's happening. Keep this notebook running. Again, this will run for 8 to 10 minutes. And then in the meantime, we're gonna just in a bit here have a look at pre-generated ones from a previous run that I pre-created just to help bridge the execution time here. And the second phase, which will start after the analysis, will be the feature engineering. So once the previous one is done, it will jump here to feature engineering. This will also run for 10 minutes. And then it will jump to model training and tuning. You can guess another probably roughly 10 minutes. And at one point, the job will complete. And then we can pull query here for the candidates, the best candidates, inspecting what happened here, doing some experiment analytics, exploring the best candidate. And then what the notebook also does at the very end is, and here's a quick spoiler, probably XGBoost will be picked as the best candidate, the best performing algorithm here. We can deploy the best performing model as an endpoint, so we can do real-time predictions here. So the notebook will do all of that for us. You can see all of the cells are lined up, so they are just waiting for the individual steps to complete. So if you've done that, so this is a good notebook to do the cell run all and not to do manually, because otherwise you would have to come back and check every 10 minutes if you can run the next one. All right, so while this is running, and I just scroll up here again, while this is running and analyzing the data, I want to show you how the results look, because we're all curious and we don't want to wait 20 minutes to see what's going on. If I jump back here into my Jupyter folder structure, you see a folder that is called Notebooks. And here we copied some pre-generated outcomes. So we basically just ran the job before and copied the results in here, so you can see what's actually happening here in a couple of minutes. And the first notebook, and don't run those because they are tied to a different job ID, which doesn't exist in your environment because it's been running somewhere else. So they probably don't completely run. Really just have a look at them, right? So the data exploration one, this is the outcome from the first phase. And this is generated by Autopilot, right? This is documentation that the service drops. So here you can see the training job name. The AutoML job did another split training validation. So basically AutoML is doing a lot of that for us. And we read 30,000 rows. We have 2 columns in the data set. One is star rating. Whoop. And the other one is, it said star rating is the one we want to predict, basically, out of the 2 columns. And it also defines the problem, right? So it says this is a multi-classification problem, multi-class classification. So it identified that we have 5 samples for classes, basically, which is our star ratings 1 to 5. And if you remember, we didn't tell the service what type of problem it is, right? So the service picked up, well, you want to predict those, and I see that's multi-class classification. So pretty smart. And it runs some, a preview again of the data set. And then it runs some statistics. So it checks for % of missing values. So in this case, 0.04, pretty low. It does some counts in here, checks for categorical, string features, text features, and really kind of looks what's needed to be done for feature engineering. Unique entries for each row, category, and yeah, calculate statistical values, mean, median, minimum, and max.
You are watching MlOps Series, live from Bootcamp AI.
So in the little data set here, not super exciting, but if you can imagine, if you run this across tens of thousands of rows, this is getting more and more interesting here. All right, but not too bad for a data exploration one. So the more interesting one, at least in my opinion, is the candidate definition. So you can open up that. And as I said, don't run. The job IDs are different because it's been running in a different environment before, but have a look what's producing, right? And your job that is currently running will produce 2 notebooks as well. So we really just show you here as a sneak peek what you expect. All right, so the candidate definition notebook here, again, lists all of the environment. It documents the technical setup here. So Jupyter Lab, Jupyter Core, IPython versions, Conda Python versions, SDK versions. So it's all documented in here. And it downloads the generated assets. So Autopilot will generate the code that is needed to do the feature engineering. It will have model candidates, etc. So this notebook here downloads all of that, and you can see here, this one was executed in another sandbox account from an AP South region. So this is why it won't run here with you. But basically then documents everything here. So again, if you run this in your account based on your jobs, you can tune this, you can execute this. It pulls in everything you need to basically replicate the model workflow. So job configurations here, roles that has been used, and don't worry that sandbox account is long shut, so don't bother with those IDs. It's just been yet another sandbox account. So candidate pipelines, so here we're using a setup to actually run those interactively here. We can see, now it's getting interesting, we can see the pipelines. So we told Autopilot to generate 3 candidate pipelines, and they're called, funnily here, DPP0 and then dash and an algorithm. So this is the data preprocessing pipeline, 0, so the first one, which uses XGBoost as an algorithm. And it documents here which data transformation it suggests. So this data transformation first transforms text using multi-column TF-IDF vectorizer. And if you hover over here, you can see down here, it's a link to a GitHub repo, SageMaker scikit-learn extension. So it points you to the exact Python script in this Git repo, which was used to do the feature engineering. And then it also merges the generated features and doing robust standard scalar with it. Is another scikit-learn library here. So it documents everything that is proposed for this pipeline. And it's going to use an XGBoost algorithm. So this is the setup here. It also pulls in a definition which instances to run it on, instance counts. And if you're a machine learning practitioner, you can take this as a baseline, right? And then just scale it from here. Maybe you want to take this and then say, okay, now let's just, size it up. Maybe let's do distributed training across 10 instances, for example. All right, the second model candidate. So here DBP1, still XGBoost. So apparently Autopilot thinks that's a good algorithm to use for classification. Again, defines what is different here. So it's still transforming the text features into vectors, but then applies different other steps, like here robust PCA and robust standard scalar. So there's a little bit of a difference. It's still going to be an XGBoost model. And yeah, here we have the third one, surprise, XGBoost. Actually, it can pick different algorithms. So when Autopilot thinks there's two algorithms that could solve the problem, it can do a multi-algorithm optimization. So it runs pipelines, and probably if I put in here, go for 10 pipelines or 10 candidates, it will try out different algorithms as well. But here, for just top 3, it's pretty sure that XGBoost will do the job pretty well. Again, code. And if I scroll down, you can see it's a very long notebook that it produces. Here's the setup for this multi-algorithm hyperparameter tuning. So in our case, we just have XGBoost here. But if for some reason it picked up another one, you could also see here that it's adding those, and then it does hyperparameter optimization across the 2 different algorithms, and it will basically split out what to test for in each. All right, so hyperparameter ranges here to optimize. So this is the range it tries to tune. Number of rounds, maximum depth of XGBoost tree, etc. And then it starts the hyperparameter job here. So everything is done. See, that is the code that we're going to execute in section 8 today in optimization manually, which is already done here with Autopilot. And we can start the tuning job here. And again, this is not to be executed. This is just what Autopilot produces as a result, right? I'm just going to show you. I'm not running anything in here. So model selection. And then at the end, it shows you the best candidates. And it creates a pipeline model. And pipeline means that it's combining the feature engineering step, the actually trained model, and then basically the post-processing. So because once you have an endpoint running, you need to have some part that is generating and feature engineering the data, right? You're gonna send in this example, like raw text, and then the first step in this model pipeline would be to transform the text into either word vectors or word embeddings. And then the model can handle that. And then the outcome, the result of the model would be maybe an index. And you want to map the index, the prediction, to maybe a label that says star rating 5, right? So it's going to get deployed as 3 containers behind that endpoint. And this is why we're talking here for pipeline model. All right, so again, do not run this notebook. This is just the candidate definitions. That is the result from our AutoML job. I just wanted to show you quickly samples, how that looks like. So I manually shut them down because they don't have our Jupyter magic. All right, so I guess my Autopilot job probably jumped into the next phase. Yeah, so analyzing done, and you can double check here, it's doing something. And yeah, it's now in the feature engineering. So keep this notebook running. Again, it's probably running for 10 minutes now. It will run another 10-15 minutes. So just keep that really open here. Don't close it. Don't stop it. Otherwise, the job executes. Perfect. So I saw a couple of questions coming in the Slack channel. I tried to answer a couple of those as well. A couple of questions on Autopilot. So where do I see those jobs? And depending on the phase you're in, you can go to the console and go to SageMaker. And then on the left side, you can see, don't have everything in here. So a more visual representation of those AutoML jobs, which are also called sometimes experiments, can be seen actually in SageMaker Studio, which is the new IDE. We're not using Studio today, but there's actually a visual representation and all of those tuning jobs and training jobs together, basically grouped by experiment, and you can drill down and you can also compare them. You get some nice metrics and comparisons. So this is basically the new IDE where you can see them visually. Right now we're doing a lot of things programmatically here. What you can do here in this standard SageMaker UI, you can see if you click here on processing jobs, you can see here some jobs being started early on. And primarily what you can see are the training jobs. So here you can see the AutoML, DM, DPP. So those are the 3 model candidate pipelines that the service created and executed. And part of the training is also the tuning job. And the tuning parent jobs are visible here in hyperparameter tuning. So here you can see tuning job. That's kind of the parent job here, and you can click in here, and you can see it executed 3 tuning runs. So if we would have set that we want to have 250 model candidates, the hyperparameter job would run 250 individual tuning runs. And this is why we kind of limited it to actually see them here completing. And again, those metrics will not be the 99% accuracy today in this workshop, because as you can see, the job just ran for the tuning job for 1 minute, right? So with 1 minute tuning, you can't really get to 99%. And this is not the intent today, right? The intent today is really show you the tools and how you can work with our services and build your machine learning pipeline. If the goal is to maximize accuracy, we would have to train and work A, on much larger data set, and B, for a longer time. So, which is not the goal today, because we all want to have a little bit back from the weekend after this. All right, so this is where you can sneak in here and look for those artifacts running. And
You are watching MlOps Series, live from Bootcamp AI.
so keep the Autopilot one if that is still running open. Let me check mine here. Model training tuning. So mine jumped now into model training tuning. That's why we saw the training jobs here in the console and the hyperparameter jobs. So let me see if it's actually completed. Yeah, so my Autopilot job in the meantime has completed. So what's happening here down here is we're polling for the candidates. So Autopilot creates this list of candidates, and we're checking here if this is set. So okay, if you see the okay, you should be good. And yeah, those are programmatic checks. And then here it's listing our 3 candidates and the objective metric, which was the validation accuracy. And you can see it's not the highest, right? It's 36%, 34, 26. But that wasn't the goal, right? We just want to like functionally show you how you can build those. And then with more data and longer runs, obviously those go up. So for now, we have 3 candidates and we have a clear winner, which is leading the pack here. So let's have a look. And you can pull in here SageMaker Analytics, capabilities, and then explore the experiment here. You pass in the name of the job, and then you can see here the listings of all of the individual components. So here you see the 3 tuning jobs, the pipeline jobs, and here also kind of a batch transformation job showing up. All right, so all of the details in this data frame. We can ask for the best candidate. So again, we're checking here candidate response, making sure you executed all the notebooks correctly and the variables are set. So we're trying to catch as many key errors here as possible and give you a hint which step it might be missing. And yeah, here, candidate name. So this one, 36% seems to be the best candidate. We can get more information here. So you can drill down as deep as you need. And also, as I said, the models are deployed as a pipeline. So Autopilot will take the code that it generated and used for doing the feature engineering and will deploy it in a container to process the incoming raw data to the model. So, and this is here the first container. And the second container then is the actual model. And the third container then basically takes the results from the model and transforms them to anything you like. So it's a pre-processing, the actual model, and the post-processing of the output. And all those 3 containers get created and built and executed behind a single model endpoint, which you can then integrate in your applications as an API. So pretty neat. Yeah, we saw XGBoost got picked. We can see here the candidate RM. So this is the unique location and identifier here within AWS land. And yeah, and I think mine, yeah, we're setting up the endpoint configuration here because we want to deploy a model. So we're creating the endpoint name here, again with the timestamp. Here you can see the names, also the variant, the production variant, which basically defines the model and the hosting resources. And then we're creating the endpoint configuration by passing the config name. And here we're passing in the settings on where to host the model, right? So in this case, we're picking an M5 large instance, single one, just now for this workshop, and create the endpoint. So let me see, in my endpoint, this will take a couple of minutes here for the endpoint being created, creating those containers, pulling down the model, everything, and host it. And once this is done, you can see here we're checking the status. It shows in service. And again, if I jump back here, because now it should show up in my UI, if you go to SageMaker and then scroll all the way down to inference and endpoints, you should see a model endpoint now showing up here. And this is basically our best candidate model from Autopilot already deployed in production and service as a real-time endpoint. And if you click here, here's the API, which you can nicely just integrate in your application to ask for invocations, predictions, inference calls. Perfect. So we're also doing this programmatically from the notebook. So nobody has to build really quick an application. So we're pulling in the SageMaker runtime through the Python SDK. And we can use that then to basically invoke the endpoint. So send a prediction request. And we're basically giving it the endpoint name. Content type is text, accepting test. And we're just creating some sample lines and then passing in the sample lines here. So let's take here, I loved it. And we invoke the endpoint and we parse the response. And you can see here it predicted a 5. So this one is good. And then we're doing another one. It's okay. And you can see it predicted a 3. So yeah, it's probably what I would classify. And then here we have another one, the worst product ever. And this one is predicting a 1. So in this case, I think Autopilot did a pretty good job in predicting and classifying our sample reviews. And those are pretty easy sample reviews, but I think it makes the point. All right. And then we're storing again the endpoint name because we're going to reuse that at a later point and show you some more things you can do with model endpoints being deployed. So we're kind of storing that information, remembering that, checking we now have 3 variables stored, and we're closing the notebook here. All right, so my Autopilot finished. If yours is running, don't worry, keep the notebook open. We can move forward. It's not stopping us from anything. So mine has finished, so I'll close mine here. And Comprehend is still running. Yeah, Comprehend will run longer, so don't worry.